Here is video 12. Now I want you to take a look at the board. We have 3 triangles. Can you see if there's anything similar about these triangles? Is there anything that looks similar about triangle 1 and triangle 2 and triangle 3? Can you see anything? Well, triangle 1, triangle 2, and triangle 3 all are right triangles. True? They all have this little box on the side, so they're all right triangles. Yes? Okay. Anything else? How about this angle? Is it the same in all 3? Yes, it is. So if this angle is 60 degrees and this is a right angle at 90 degrees, 90, let me make this a little bit bigger, 90 degrees and 60 degrees will give me 150 degrees. So this angle and this angle added up together give me 150 degrees. So what's this angle here? What is it? Well, it's 180 degrees minus 150, which will be 30 degrees. And if this one's 30 degrees, is this 30 degrees? Sure it is. In each of these triangles, the angles are the same. The sides aren't the same, they're all different sides, but the angles are the same. And whenever you have triangles where the angles are the same measurement, these are called similar triangles. So these 3 triangles are similar. And whenever you have similar triangles, well then something very interesting will happen in regards to their lengths and in regards to their sides. And the thing that's very interesting that will happen is that their sides will always be in proportion. Let me show you. If this side was labeled A and this side was labeled B, and this side was labeled C and this side was D, then we could say that the relationship between the sides is A is to B as C is to D. Kind of like those chickens and pigs, huh? Chickens to pigs and chickens to pigs. That was in the ratio and proportion video. So the relationship between side A and side B is the same as the relationship between side C and side D. And if this is really true, then if I know what side A is and what side B is and what side C is, well then guess what? I can easily find out what the measurement to side D is. And how am I going to do that? I'm going to use ratio and proportion because the sides are in proportion. I am going to say 10 is to 5 as 2 is to D. So A is to B as C is to D. 10 is to 5 as 2 is to D. And 5 times 2 divided by 10 is 10 into 10 goes 1. And so how long is D? It's 1. 1. So 10 is to 5 as 2 is to 1. The sides are in proportion. And that's great because if I know 3 of the sides, I can find out what the 4th is. And I can do this because these triangles are similar triangles. Their angles have the same measurement. Let's try again. If this triangle is, this side of this triangle is 22 inches, and I don't know what this side is, but I know these. I can say 10 is to 5 as 22 is to question mark. And what am I going to do? I'm going to multiply and divide. Multiply and divide. So 22 times 5 is 110. And 10 divided into 110 will go 11 times. So the question mark will equal 11. So this side, or side D, is 11. The sides are in proportion. Now, similar triangles don't only have to be right triangles. It's any triangles that have the same angle measurement. If their sides are different, their sides are in proportion. So these are similar triangles. Now, I want to show you how this happens sometimes in questions. So get ready. Let me erase the board first. And then I want you to think about nature for a minute. I want you to think about the sun and how it shines. Okay? The sun shines down like this, and guess what? The sun's rays are parallel. Did you know that? The sun's rays are parallel, so that when the sun shines on a tree, okay, and it makes a shadow like this. Let's say here's the sun rays, and it makes a shadow. You'll see that right here we have a right angle, and we'll have an angle caused by the sun's rays and the edge of the shadow. Now, remember, the sun's rays are parallel. So if over here we have a small flagpole, and it too has a shadow that's caused by the rays of the sun, well, let's make it a little bit more like this. It too will cause an angle to form. And because these rays are parallel, these angles will be equal. So here we have similar triangles caused by the rays of the sun making shadows from trees and flagpoles. Now let's say that this tree is 12 feet and this shadow is 6 feet and this flagpole is 5 feet, and I want to find out how much of a shadow there is here. Again, I can use the idea that the sides are in proportion. A is to B as C is to D. And what am I going to do? Well, I'm going to say A is to B as C is to D, and I'm going to substitute. What's A? 12 is to 6. Let me make this a little bit better. 12 is to 6 as 5 is to D. And you know how to solve this, right? All you have to do is multiply the diagonals and divide by the next number. So 6 times 5 is 30, and divided by 12, let's try that again, 12 into 30 is going to go 24 with 6 twelfths left over, which equals 1/2. So here we have 2 1/2. So what is D? D is 2 1/2. How long is this shadow? Why, it's 2 1/2 feet. And there it is. Similar triangles. Let's try it again. Let's see if you really understand this. Let's try it one more time. Instead of a tree and a flagpole, let us have a building, a small building, but a building, and a shadow. And let's have a tree, another tree. Don't laugh at my trees. And a shadow. So here we go. We have a building that's 20 feet tall. It's a short building with a small shadow of 4 feet. And here we have a tree that is 12 feet tall. And I want to know how big the shadow is. And remember, the sun's rays are making this angle equal, to that angle. So this angle is equal, this angle is equal, these two are 90-degree angles. These two angles are equal, so that means that these two angles are equal. All three angles are equal. That means this angle equals this angle. This angle equals this angle. This angle equals this angle. So therefore, we have similar triangles. And if we have similar triangles, their sides are in proportion. So I can say that 20 is to 4 as 12 is to question mark. And what do? I multiply 4 times 12, and 4 times 12 is 48. And then I divide by 20. So 20 into 48 goes 2 and 8/20 left over, And 4 into 8 goes 2, 4 into 20 goes 5. So this shadow, this question mark, would be 2 and 2/5. This shadow would be 2 and 2/5. Can you see how to figure this out? This is similar triangles. Always their sides are in proportion. Sides are in proportion. Okay, I want to show you something else. And what I'd like you to show you is something else about angles. I'm going to tell you about complementary and supplementary angles. Now, complementary angles are two angles that equal 90 degrees. And supplementary angles are two angles that equal 180 degrees. Now, the way I remember this is complementary, C, comes before S in the alphabet, and 90 comes before 180 when you're counting. So I always remember complementary comes first, 92 angles equaling 90 degrees. Supplementary, 2 angles equaling 180 degrees. So if I ask you, if I say, what is the complement of a 2-degree angle? What are you going to tell me? Well, the complement is 88 degrees, because 88 plus 2 equals 90 degrees. Now, if I asked you, what is the supplement of a 20-degree angle? Well, the supplement is 180 minus 20, which equals 160, because supplementary angles are 2 angles that equal 180 degrees. So the complement of an angle is the other angle that makes it equal to 90 degrees. The supplement of an angle is the other angle that makes those 2 angles, the sum, equal 180 degrees. So let's try again. Let me say, if I had a 40-degree angle, could you tell me what is the complement? The complement of a 40-degree angle would be 50 degrees, because 40 plus 50 equals 90. What would be the supplement of a 40-degree angle? Well, the supplement would be 140 degrees, because 140 plus 40 equals 180 degrees. Getting the idea? Complementary and supplementary angles. Complementary, 2 angles added up together that equal 90 degrees. Supplementary are 2 angles added up together that equal 180 degrees. Now, let's try again. How about we have a 60-degree angle? What would be the complement of a 60-degree angle? Why, it would be 30 degrees, because 60 plus 30 equals 90. And what would be the supplement of a 60-degree angle? Well, that would be 180 minus 60, which would equal 120 degrees. 60 plus 120 equals 180 degrees. So these are complementary and supplementary angles. And you'll have plenty of practice in Workbook 3 in complementary and supplementary angles. There's one other thing I want to tell you about, and that's called the Pythagorean Theorem. Now, Pythagoras was a great Greek philosopher, musician, and he dabbled in mathematics. He was a brilliant mathematician, and something that he liked an awful lot were right triangles, and he found out a lot of interesting information about right triangles. So let's take a look at this right triangle on the board. So here we have a right triangle, and what he found out is that, well, before I tell you what he found out, let me tell you a little bit about the names of the sides of these triangles. This slanted line, this diagonal line here, it's called the hypotenuse. Hypotenuse. And these 2 lines here, I always think about, there was an advertisement on TV where they said, nothing beats a great pair of legs, according to this advertisement, and these are the legs. So he named the legs A and B, and he named the hypotenuse C. So he found out that the square of A plus the square of B will always, in a right triangle, equal the square of C. Now you remember about squares? If I have 6 squared, that means 6 times 6, which equals 36. Remember this? This is the base, this is the exponent. And if I wanted to find the square root of 36, it would be that number multiplied by itself that would equal 36, and that would be 6. And how about if we had, 7 squared? 7 squared equals 7 times 7, and 7 times 7 is 49, and the square root of 49 would equal 7, because 7 times 7 equals 49. Remember this? Okay, so we have the square of A plus the square of B will equal the square of c. Now I know someone is telling me what's so important about that, but let me tell you that if I don't know what c is and I need to find out this, I can find it out by squaring this and adding them together. So that's what we're going to do. We're going to find out what c equals. And how are we going to do it? We are going to use the Pythagorean Theorem. We are going to use a squared plus b squared equals c squared. So I have a is 3, so we have 3 squared, and b is 4, so I have 4 squared equals c squared. And so now what do I have? I have 3 times 3. Remember squared? 3 times 3 is 9, plus 4 times 4 is 16, and that equals c squared. And what's 9 and 16? Why, it's 25 equals c squared. Now, is 25 c? Is 25 c? No. 25 is c squared. 25 equals c times c. So I am looking for the square root of 25. I want to find one number multiplied by itself that will equal 25. And what is it? Why, it's 5. The square root of 25 is 5. So c will equal 5. Isn't 5 times 5 25? So what is this hypotenuse? It's 5. How did I find it? A squared plus b squared equals c squared. Now I tell all my students when we get to this point to make sure that they go over their squares from 1 all the way down to 20. I say go 1 times 1 is 1, 2 times 2 is 4. Go all the way down to 20. We usually know the first 10 pretty well. It's from 10 to 20 that we might not know so well, and if you go over them, you'll be surprised how those numbers will stick in your head, and you'll feel so smart when you know that the square root of 225 is 15. So get ready. We have another problem to do. I'd like to use the Pythagorean Theorem again. And so here we go. Let's say that this is 9, and this is 12, and this is b, and we want to find out what c equals. Again, we're going to use a squared plus b squared equals c squared. A is 9, so this is 9 squared plus 12 squared equals c squared. 9 times 9 is 81, plus 12 times 12 is 144, and that equals c squared, or c times c. Now 144 plus 81 is 225. So 225 is c squared. And guess what? I know that the square root of 225 is 15. And the reason I know it is because I've done my homework and I did my squares from 1 to 20. Now, if you didn't know that, you could kind of estimate. You could say, well, 144 is 12 times 12, so it's about 14 or 15. And you could try 14 and see what happens and then go on to 15. So what is c? Well, c equals 15. Now, sometimes what happens in problems is they give you c and they leave you c and b and they leave out a. And I want to show you how you can do that. You can use the same rule, a squared plus b squared equals c squared. And this time we're going to leave out a, and we're going to say 12 squared and 15 squared. Again, I know that a squared plus 144 equals 225. Now, I'm not interested in finding c squared. I need to find out what this number is. And you'll be learning how to do this in the algebra videos. But let me show you real briefly what you're going to do. You're going to subtract 144 from 225. And you're going to end up with a squared equals 81. And what is the square root of 81? Well, a will equal 9. So, this is the Pythagorean Theorem. What I would like you to do is I would like you to please go to Workbook 3, Learn Math Quickly. I'd like you to do Part 1, pages 46 to 47, Part 2, pages 48 to 49. And you can look on the review sheet on page 50, which is a good geometry review sheet. And please also do the cumulative geometry test, Test 1 and Test 2. They start on page 51. and I'll meet you back here for video 13, algebra.